Okay, so a final topic we're going to cover in the first lesson will be the topic of data structures. In Python, we're going to cover all the basic data structures that we have. We're going to cover lists, tuples, dictionaries, and sets. So let's start off with lists, like you see here. So a list is essentially some sequence of elements. So it's a wrapper for other objects. It's an object that contains other objects. It's very similar to similar concepts in other programming languages. You might know, for example, arrays in some languages. So you can see the way we define it. We use the square brackets, and then we just start listing some values with comma separation between them. So you can see here we have a list with 6 values. We have 1, 2, 3 integers. Then we have a string A and 2 more integers, 4 and 5. And we can print list and just get the entire list, everything within it, printed to the screen. And you can see that when we check the type of the list, we get that it's a type list. Like with strings, we can use the len function to get the length of the list, how many elements there are within it. And you can see we get the result, an integer 6. And again, like strings, we can use this square bracket notation to select items or to do slicing. So we can select the second element. Again, this is a 0-based index. So 1 would be the second element, and 3 will be the fourth element. And you can see we indeed print them. Now, lists are very versatile, and unlike, again, in other programming languages, like with arrays, which are limited and restricted to a specific type, with lists, like everything in Python, we have it as a dynamic language, like we said. So we have no restriction on types, and lists can contain objects of every type we want, and we can also mix together various types, like we saw here that we mixed integers and strings, and there is no problem with it. So here you can see that we can even have a list within a list. So you see here we have a list with 3 elements. So the first 2 are numbers, and then the third element is in itself a list, a more inner list within the outer list, a list of 2 elements, 1 and 2. And we can even have a list within a list within a list, like you can see in the next example here. So how can we extend and add more elements to a list? So as you can see, we can initiate a list with 3 elements, and then we can use the append function, which is very useful, to add to the end of the list another element that we want. Here we add 4. So you see when we print the list, we get it now it's containing 1, 2, 3, and 4. A similar way to do it is the plus equals operator that gets another list. So this actually extends the original list with a new list. And if we do it with a list that contains just 1 element, then this will essentially add this new element to the original list. So you can see that following this syntax, we get 1, 2, 3, 4, and 5. And like I said, it can be a list with more than 1 element. If we add a list with 2 elements, it will add those 2 elements. So it will essentially concatenate the 2 lists together. Another way to do it is to use the extend function, which again, given a list, it will concatenate it and add those elements to the end of the original list. And you can see that now A contains 8 and 9 as well. Make sure that you do use the extend function if you want to add the elements within a list, and not use the append function. If you use the append function and you give it a list, what will happen is not exactly what you want. You will just, maybe this is what you want, but it will be something differently. So what you will end up getting, if you do that, you will get that essentially you add a new element. That's what append does. It gets an element and puts it within the list. So when you do append to a list, you will essentially get a new element within the list, which is, in this case, a list. So on top of all the elements within the original list, you will then have that the 10th element is simply a list of two numbers. And likewise, if you give it a list of one number, you will get the list as an element, not the element itself. Okay, so pay attention to that. I will also state that although you can see people very often use the plus equals operator for list, it's actually less recommended to do that, and I recommend you to, most of the time, to use the extend and append functions. The reason is that they are more efficient, and why exactly they are more efficient is something you're going to encounter in an upcoming bonus question, so I will not ruin the surprise. But I will just say as a general advice that it's better to use the append and extend and not this syntax. Okay, so I said that a list can contain essentially everything. Surprisingly and very strangely, it even applies to the list itself. So in Python, you can even have the very strange scenario of a list contained within itself. So you can have, if I append a list to itself, what I end up getting is that the list itself is the 5th element, in this case, of the original list. And that actually creates this recursive pattern. So when I print the list L, or I print the 5th element, you can see that I actually get the same thing because the list is its 5th element. And you see that if I compare them, it's actually true. Okay, so we have this strange situation that the list is contained within itself. So for example, if I get the 5th element, I get a reference to the list, and then if I get the 3rd element, I get 3. And I can do that as many times as I want. Each time I get, again, a reference to the original list, so it essentially does nothing. I don't think it's really that useful, but just so you know that it's something you can do in Python. Of course, if I try to use the plus equal operator with an integer, then it's not something that is well defined, and I get a type error. Okay, I cannot use it when A is a list. It doesn't make sense to add a number to it. And again, like we saw before, we can use the syntax to increase and add new elements to the list, and we can even do that to concatenate a list to itself using the plus equals operator. And then we essentially get that A will be a new list with all the original elements repeating twice. So everything until E here, and then everything again. And like with strings and numbers, we can use the multiply operator, and this works pretty much like it works with strings. So essentially, you will get the list concatenated to itself a given number of times, 3 in this case. So we'll get 1, 2, 3, 1, 2, 3, 1, 2, 3. Or you can use the multiply equals operator to take the result and assign it back to A, like we saw before. And like with strings, slicing works in pretty much the same manner, only that, of course, we get a list as a result and not a string. Okay, so you can see we can slice everything between the 4th to the 8th element if we want, or we can get everything in reversed order, simply reversing the list like you see here. So as you saw, strings and lists have very much in common. So they are both some sort of containers that can be sliced and iterated through. So essentially, a list is a more generic container. It can contain everything, whereas string is simply a sequence of letters, so it's more restricted. If we want, we can convert a string to a list, and then essentially we will just get a list where each one of the letters is a different element. So instead of a string of size 4, we will get a list of size 4, where each element of the list is a letter of the original string. Okay? Now, if we try to convert it back to string, you might expect that it will undo. So converting a string to a list and then converting it back to string will give you the original string. But that's not actually the case. If you try to convert a list into a string, even if it's a list of single letters, you will get up something quite differently. You will get some string representation of the list, like you see here. So this will actually be a string saying square brackets, single quotes, a single quote, comma, space, like everything you see here, just as a string. So that's not the same as a 4-letter string of A, C, G, and T. It's not the same. Actually, if you want to undo that, we can use instead the join function of a string. The way this works is we get some string and then we use the dot join. So it's a join bound function that is bound to this string, and then we give it a list of strings. And what it essentially does, it just concatenates everything within this list of strings. So it concatenates all the elements together, and between them it puts the string that you see here on the left side. So if we give an empty string, it simply concatenates everything together, and we get back the original string of 4 letters, A, C, G, and T. But we can also use a different separator. Like you can see here, we can use a space, and then we'll get a string with those letters separated by, the separator now is a space, so separated by space. And we can also give a separator of more than one letter. We can give a 2-letter separator of a comma and a space, and then you see everything is separated in this way. Now, like with strings, we can use a for loop to iterate through all the elements of a list. So you can see here we have a list of 4 elements, and we use a for loop, and each time we get a base, and we can print it, and we get 4 iterations of the loop. Okay, so this works exactly the same like iterating on a string, no difference. Of course, lists are more versatile. So if we use lists, we don't necessarily iterate through single letters. We can also iterate through more complex values, and we are going to see examples of that. Okay, and like with strings, we can use the in statement to check whether some element is contained within a list. So we can check whether T is an element of this list, and the answer is true. Whether U, no. And again, this works quite similar to how it works with strings. So to remind you, if I check whether U is a substring of this string, the answer is no. But you should note that those two don't work exactly the same. For example, if I try to check whether AC is in a string, the answer is true because AC is a substring of this string. But if I first convert it to a list and then check whether AC is within this list, this has a different interpretation. Now what I'm asking is whether AC is an element of this 4-element list, and the answer is no. Because now when I convert this string into a list, I get a list of 4 distinct elements, and none of them is exactly A and C. So the in statement within lists, it checks whether I have an element of the list, whereas for strings, it checks whether it's a substring. It's a subtle difference, but it's an important difference, so it's not exactly the same. Another useful function in Python that is related to lists is the range function, which, if you convert it to a list, it will simply give you a list of all the numbers until the number you give it. So if you give it 10, you will get 0, 1, 2, 3, all the way to 9. So again, like we saw in many examples before, it's not including the value itself. So it's everything up to this value, not including. Okay, so that's what happened when I converted it to a list. You will notice, by the way, that if I don't convert it to a list, I don't exactly get a list. I get a range object, which is something different. Okay, we are going to understand it more deeply later on. And I will also state that this is, again, one of the differences between Python 2 and Python 3. So in Python 2, it is actually used to return a list when you use the range function. But in Python 3, they changed it for good reasons, and now it doesn't give you directly a list, it gives you something that you can convert to a list if you want. Okay, and like with slicing, it works in a somewhat similar way. So if I want everything between 3 to 6, not including 6, I can give range of 3, 6, and you can see I get 3, 4, 5. I could also specify an interval size, so I can get everything between 0 to 9 with difference of 2 between each two numbers. And I get 0, 2, 4, 6, 8. But unlike in slicing, I cannot give here a negative number. So you might expect that if I give it 0 to 10 minus 1, I will get everything from 9 to 0 in a backwards order. But it doesn't work that way. Instead, I get an empty list. If you actually want to get all the numbers in reversed order, you can use the reversed function, which given some list or list-like object, it will reverse it. So I can create range of 10, I can use the reversed function, and that I can convert it to a list, and you see I get everything from 9 to 0. Now I said that range doesn't exactly give a list, it gives something different. We're going to understand exactly what it is again later on. It's going to actually appear in an upcoming bonus question, so stay tuned on that. But it does share a lot of similarities to how lists work. So like lists and strings, we can just iterate through this object, no matter what it is right now. So I can do a for loop on range 5, and this will give me 5 iterations each time I will get the next number. So 0, 1, 2, 3, 4, each time I calculate and print the square of the number. Okay, so that was lists. Now we're going to speak about a different data type that is actually quite similar, but has some mild minor distinctions. And that data type we're going to speak about is called a tuple. So unlike a list, which is defined by square brackets, a tuple is defined by regular round parentheses. So you can see I can create a list with 3 elements, or I can create a tuple with the same 3 elements, and I can print either of those, and you can see they're printed differently. And if I try to compare them, I actually get a false. So a list of 3 elements is not the same as a tuple with the exact 3 elements. And there are some important distinctions between tuples to lists. One important distinction is that while lists are dynamic and you can extend them and shrink them and change their values, tuples in some way should be thought of as some frozen list. So you get a list and you cannot really change it. Again, this will be more clarified in an upcoming bonus question. But for now, keep in mind that you cannot really change the value of a tuple. So for example, if we try to use the append function on tuple, we get an attribute error saying that the tuple is not even, it doesn't even have an append function. So you cannot really change the original tuple, but if you want, you can create a new tuple. So for example, you can use the plus operator to take one tuple and then another tuple, and you can concatenate them together and get a new third tuple. Okay, and this doesn't contrast what I just say about you not being able to change tuples, because again, we don't change either of the 2 tuples here. We actually get a new tuple of 5 elements when you try to concatenate 2 existing tuples. And like I showed you at the beginning of the lesson, we can use this nice syntax that we can actually do multiple assignments within the same line in Python. So if I give some collection, it can be a list or a tuple or anything that has exactly 3 elements, and I assign it to 3 different variables. So Python is smart. It knows to take the first one and to put them into A, the second to assign into B, and the third to assign into C. And you can see I print them, and each one gets its appropriate value. And this works the same with the list. Again, it has to be the exact same number for it to work, but if it is, then no problem. So you can see here in this example, again, I give it just 2 elements and it won't work. It says too many values to unpack. So according to the left-hand side, it expects 2 values, but I give it 3 values. So too many values. So again, if you remember, I showed you if I don't really care about the first and the third elements, I just want the middle one, I can use this underscore variable as some kind of placeholder, and I can assign it, and then I would get b being equal to the second element. And the first and the third, I don't really care about. So I can even define a tuple with just one element, like you see here. And the way to do that is it's very important to add this comma at the end. So whereas with lists, I don't really need it. I can just, create a list using this syntax with the square brackets. With a tuple, it won't work because a tuple uses parentheses and not square brackets. And parentheses are also used for other purposes in Python. So for example, it can be used for, for determining the order of arithmetic expressions, for example. So if I do something like that, it means to Python that I want the 1 plus 4 to be calculated, and then the result to multiply by 3. So if I do something like that, it just tells Python that I want this expression to be evaluated separately. So these parentheses are already used for this purpose. If I actually want to get a tuple, I need to put this trailing comma in the end. And now Python knows that I actually want to create a tuple with just one element. Okay, so notice this comma, it's actually very important. Okay, and once defining this kind of tuple, I can also assign it back to some variable. And the way to do that is to use this other of these two syntax will give you the same, will produce the same result. So you can either do a comma equals some tuple or list or anything with one value, or you can even use the parentheses around it. Again, it doesn't matter, it will do the same thing. But the crucial thing is that you do this kind of assignment, what you get to be put within A, the kind of assignment that you will get that A is not equal to the list or the tuple itself. Rather, it will be assigned the value within the tuple. And that's a very, very, very important distinction. Okay, we are going to see many examples of this along this course. And if you're not used to Python, this may look like a very strange syntax, and it's very, very easy to overlook, but it's crucial. So try to train yourself to pay attention to those commas. In both of those examples, it's very important, and it really changes everything. Okay, so if I do something like that, if I do A equals this monotuple, and then I print A, you can see that what I get is actually the tuple itself, not the value within it. Okay, whereas if I do that, and then print A, now A is not a tuple, but the element within the tuple. Okay, it's a very important distinction. It doesn't work the same way. So now, for example, if I want to calculate A plus 2, no problem, I can do that. I can take 1, add 2, and get 3. But in this example, if I do plus 2, I get a type error because I cannot concatenate a tuple with an integer. Okay, so this is not the same thing. This comma changes everything, and it's very important to pay attention to that and not to overlook what you see here. Okay. Another thing I wanted to speak about, which is somewhat related to tuples, is the topic of formatting strings. So this is actually a very nice syntax that we have in Python and some other languages. So the way this works, we can actually create some string that has some placeholders within it. So for example, we want to have a string saying this number is, and then some number. And we use, you see here, we use a %d to mark some integer placeholder that we then want to assign some integer value within it when we evaluate the string. So to do that, we then outside of the string, we use the percentage operator and then give it some value which has to be integer in this case, okay, because percentage %d is a placeholder for an integer. And you see what we end up getting when we do that. We can assign it to s, and now s is a string that is created from this template that we see here after replacing this placeholder with this number. And we get a string. The number is 5, period. Now the nice thing about it is that we can actually do multiple assignments within the same template. So you can see here we can have some template, a string, that has 3 different placeholders for 3 different integers. So we have 3 percentage %d placeholders, and then again we use the percentage operator, and the value we give it, instead of a single value like you see here, we give it actually a tuple with 3 different elements. And Python knows to take the first one of them and to assign them to the first placeholder, and to take the second and to assign it to the second placeholder, and the third to the third placeholder. And you see we get the evaluated string to be the numbers are 5, 6, 7. And if we want, we can even give it a tuple with just one element, like you see here. So we can give it a tuple with 5, and it will produce the same thing as just giving 5. So if it's just one element we want to assign, if we just have one placeholder, we can either just give the value directly, or we can give it a tuple with just one value. It works the same way. But if we have multiple values that we want to put within the string, then we must give it a tuple with those exact values. Now, we can also do it with different types. We saw that d indicates an integer, but we can also use a percentage %s to indicate a string, or a percentage %f to indicate a float. And you can see that now we expect Python expects us to give it a tuple with a string, an integer, and a float. And you can see that even though in this example we gave it 2 times 6, 2 times integer 6, because once we used d and then the other times we used f, so the first integer is evaluated as an integer, and you can see 6 is an integer, whereas the second 6 is evaluated within a float, and then it becomes 6.00000, and it's a float. Okay, so if we have an automatic simple conversion, we can actually give something else, and Python will know how to convert it. So it knows how to convert an integer into float. And it also knows to do it vice versa, actually. It knows how to take a float and to convert it into an integer, giving just the whole part of the number. So if you put a percentage %d, this will be 5. If it were f, it would be 5.50000, like you see here. Now, I mentioned the syntax here after we spoke about tuples, because this syntax is actually unique to tuples. So when we do that, we actually need to provide the values as a tuple. It doesn't work if you give it a list, like you see here. So this works because we have 2 values within a tuple. This won't work because it's a list, not a tuple. We can actually convert it to a tuple if we want, and then it should work. Okay, so we can take these 2 elements list and convert it to a 2-element tuple, and then to assign it within this string. And this also works other ways, so we can take range 3, convert it to a tuple, and then assign it to a string that has 3 placeholders, like you see here. Now, like in other cases that we saw, it's very important to make sure that you give the exact same needed number of arguments. Okay, so if we give it 3 values within a tuple, and we have only 2 placeholders, we will get a typo saying not all arguments converted during string formatting. Okay, so it's important to have the same number. And like we mentioned, so Python automatically knows how to do some conversions. So if we use, for example, %s, and we give it an integer, no problem. Python will convert the integer into a string and put it within the string. But Python doesn't know to do it the other way around. So if it expects to get an integer and we give it a string, even though the string can be converted into an integer, Python actually doesn't know how to do that. And we will have to do the conversion ourselves if we want it to work like this. Another nice thing this can be used for is to format floating numbers in some precision. So if we have a number that is that has a very large precision, so it has many digits, sometimes, very often, we don't want it to be printed the way it is. So if we just did string formatting in this way, you see we get too many digits and we're not interested in it. We can have this nice syntax of percentage dot and then some number and then f, saying to Python that we want it to be a floating number, but we want to present it only with 2 significant digits. Okay? So it will take 2 decimal digits and do some rounding and throw everything else, and we'll get a nicer representation of this number, which is in the precision that we want it to be. Okay, so we spoke about lists, we spoke about tuples, we had a discussion about string formatting. Now let's speak about dictionaries. So lists, I think, are very intuitive to people, especially people which have at least a minimal experience with programming, which would be everyone who is listening to this course. Dictionaries very often are more confusing to people, but I think are very, very important nonetheless. And in this course, we're going to use dictionaries actually quite a lot because it's a very, very useful data structure. So let's try to understand what dictionaries are and how they can be used. So the way to think about a dictionary is some kind of a mapping between keys to values. So for example, we can have a dictionary mapping the integer 1 to the string saying 1, and the integer of 2 to a string saying 2, and the integer of 3 to a string saying 3. And we do that, you can see, within those curly brackets syntax that we have here. Okay, so this creates a dictionary, and we can print it and just get a dictionary. And if we check its type, we see that it's of type dictionary. And like with lists and tuples, we can use the square bracket syntax to select a specific item from within a dictionary. And we give it a 2, so it will give us whatever 2 is mapping to. So in this case, 2 maps to the string 2. So this will give us the value 2. Now this may look a little bit like the way this works with lists, but it's important to say that this item selection in dictionary actually does something completely different than what it does in lists. Okay? So in lists, it simply gives us the element. If we give it 2, it will give us the element in the 3rd position. Okay? But that's not what it does in dictionary. In dictionary, it actually doesn't care about the index or position of different elements. In fact, dictionaries don't even have ordering. They don't have indices. So we're actually not guaranteed to have any preservation of the order. So in this example, we can see that when we print the dictionary, it does in fact preserve the order. So it has this element first, and this one second, and this entry goes last. But it's actually not guaranteed, and it actually varies between different versions of Python. So if you use a different version of Python, you can actually end up with different ordering. But the bottom line, what I'm trying to say is that once you define a dictionary, you cannot really have any guarantee about what order it's going to be in. So sometimes you can create this dictionary, and then when you print it, you can actually see that it actually prints the different entries in different order. So you will always, of course, have each key mapping to the right value, but the order between the pairs of keys and values will not necessarily be the same. So when we do a lookup within a dictionary within some key value, then it actually does a lookup. It checks which entry within the dictionary has this key, and it will give you the corresponding value, but it doesn't care about the ordering, and it doesn't treat it like an index. And in fact, it doesn't even have to be an integer. So in this example, we have that the keys are integers. So it looks like some item selection within a list. But very often, we will actually define dictionaries that have keys which are not integers. And then when we do this lookup within a dictionary, we won't even give it an integer. We'll give it some other type. Okay, so the bottom line is, although it looks similar to item selection in list, it's something completely different, and it simply gives you the corresponding value. That's what it does. And if we give it a key that doesn't exist, unlike in a list where we get some index error, here we get a key error. So it actually says that 4 is not a valid key within this dictionary. We have 1, we have 2, we have 3, but 4 is not a key of this dictionary. So we get a key error. Now, sometimes we want to do a lookup within a dictionary for some key that we're not sure whether it exists or not. And if we don't want to get an error in this case, we can, instead of using the square bracket lookup syntax, we can just use the get function and then give it some key. And if this key is within the dictionary, it will be the same as the square brackets. We will simply get the value corresponding to that key. But if this key is not contained within the dictionary, like in this example, we're going to simply get the none value. So this is, if you remember, we saw the none value at the beginning of the lesson. So here you have an example where this is actually useful. So instead of getting an error, you can just get whatever value, or you can get none if the key is not within the dictionary. And then you can simply check what you get and see whether it's none or not, perhaps. The get function can also have an optional second argument that, if given, will be treated as the default value. Okay, so the default value is none. So if you don't give a second argument and you use the get function and the key doesn't exist, you will get a none. But if you give a concrete default value and the key doesn't exist, you will simply get this default value that you ask for. Okay, so when you do that, Python will check whether 4 is within this dictionary. If it is, you will get a corresponding value. And if it's not, you will get this string that you asked for. Some additional useful functions for dictionaries. You have the keys function, which, given a dictionary, will give you all the different keys within this dictionary. You have the values, which will give you all the different values of the dictionary. And you also have items, which will give you all the pairings of the different items within the dictionary. So each item is a pair of key and value. And you can see what you end up getting. You get something that is similar to a list. You can actually even convert it to a list if you want. And within this list, container, you have the 3 different items of the dictionary. Each of them is actually a tuple with exactly 2 elements, where the first one is always the key and the second one is always the value. And actually, the items function of a dictionary is very useful in Python, especially if you want to do some for loop that iterates through the items of the dictionary. So we can do something like for key, comma, value in dictionary items. So if you remember, this gives us a list-like sequence of 3 items. Each one is a tuple with exactly 2 elements. And then we can assign each time the first one into key and the second one into value. And then we can do whatever we want with the key value. So in each iteration, we're going to get the key variable to have the key of the item, and we have value being the value of the item. And then, for example, we can print 1 maps to 1, 2 maps to 2, 3 maps to 3, or I can create whatever code I want within the for loop. Okay, now if I want to add a new item into a dictionary, I actually don't need to use any append function or something like that. I can simply use a simple assignment. So I can take the dictionary, use the square bracket syntax to access the key 4, and then assign it the value 4, like you see here. And now when I print the dictionary, you can see that a new item was added, mapping the integer 4 to the string 4. Another way to extend a given dictionary, we can create another dictionary, for example 5 mapping to 5, 6 mapping to 6, and then we can take the first dictionary, use the update function of this dictionary, and give it another dictionary, and this will actually map all the values, all the items given by the second dictionary, and put them into the first dictionary. So you can see now we have 5 mapping to 5 and 6 mapping to 6. If we want to remove an item from a dictionary, we can use the del statement and use the square brackets to refer to a specific key. And as you can see, following this, we actually delete the item that has the key 3. So we still have 1 and 2, but no more 3. And by the way, the statement del can be used in another context. It can also be used sometimes to delete variables that you no longer need or want to use if you want to free up the memory, say. So for example, we can define a variable a and assign it the value 55. Now, if I didn't do this deletion, of course, if I tried to print a, I would get the value. But let's say I don't want this variable anymore. I can use, again, the del statement and give a variable. And now this variable is deleted altogether. And if I try to use it, I get a name error that a is actually not defined. Another way to create a dictionary is to take a list of tuples and to convert it into a dictionary. So when we do that, we actually expect to have a list with tuples where each tuple has exactly 2 elements. So it's just a pair of key and value. And then Python knows to take those tuples and to treat them as a dictionary where each time you have the first one key mapping to the second one the value. And we end up with this dictionary. Okay, so I think now might be a good time to see a concrete example where dictionaries can come up and be quite handy. So let's say we want to take a DNA sequence, like you see here, and to convert it into an RNA sequence. So one nice way to do that is to create a dictionary mapping each DNA nucleotide to its corresponding RNA nucleotide. So you can have A mapping to A, C mapping to C, G to G, and only T turns into a U. So we can now iterate through all the nucleotide within this given DNA sequence, and we initiate an RNA letters list, which is an empty list. And on each iteration of the for loop, we take this nucleotide, we ask for the corresponding value within this dictionary. So we will get whatever RNA nucleotide corresponds to this given DNA nucleotide. Okay, so A, C, and G will remain as they are, whereas T will turn into a U. And then we simply append it into this list of RNA letters that we created. And in the end, we use the join function that we saw to concatenate it together and get a string instead of this list. So we can see we end up getting a string that is the corresponding RNA for the given DNA sequence. Another thing that is important to say about dictionaries is that the keys of dictionaries actually need to be, they cannot be anything. So we will explain it in more details in an upcoming bonus question, what exactly are the limitations. But for now, I will say that you cannot have lists as the keys of a dictionary, okay? So we can have tuples if we want. We can have tuples as keys of dictionary. This works. But if we try to give lists, you can see I get a type error, and this actually doesn't work. And why exactly it doesn't work? Like I said, it will be explained in an upcoming bonus question. Okay, so we spoke about lists, we spoke about tuples, we spoke about dictionaries. A final data type that I wanted to discuss is set. So the way to define a set is to use, again, these curly brackets like with dictionary. But unlike dictionary, we don't have the columns in the middle mapping something to something else. So if we have those curly brackets and just, a sequence of elements without the columns and the mappings, then Python knows that this is not a dictionary, this is a set in this example. Okay, and a set is very similar to a list, but it has two important distinctions. One thing is that within sets we do not have duplicates. So you can see here I try to define a set with some elements occurring more than once. So I have 1 happening 3 times and I have 5 occurring 2 times. But you see when I try to print a set, I actually get each one just once. So it gives me just the unique values that I have here. So I don't have duplicates. So with lists, I'm allowed to have the same element occurring more than once. But with sets, I'm actually not allowed to have that. And another important distinction, whereas lists have a defined order like we saw, okay, they preserve the order of the elements, it actually matters for them. Sets are more like dictionaries in this respect. They don't care about ordering, and you have no guarantee whatsoever what kind of ordering it's going to end up with. Okay, so a set is some collection of elements where you don't really have any ordering of the elements and you don't have repetitions. So just a unique set of values. Now the type of a set is set. And I can also create a set by converting some other collections. So for example, I can take a list and convert it to a set. And this works the same way like we see here. Again, I will get just unique values, and I will not necessarily get the same ordering. Okay, so what is it useful for? So one example where it's actually useful is when we want to count unique elements within something. So let's say we have some DNA sequence of 22 letters, and we want to check not only how many letters we have in total within this string, we also want to count how many unique letters we have. So one way to do that is to take this string, to convert it to a set, okay? And when we convert it to a set, we just get the unique letters within it, just A, G, and T without repetitions. And then when we check the length of that, we actually get the number of unique letters within the string. So one example why it might be good for. Another property of sets which make it useful is that it's actually much faster to do a lookup within a set. So let's see an example. Let's say we have a very long list. So we take all the numbers between 0 to 1 million. So we have a list with 1 million elements. So one time we have it as a list, the second time we convert it to a set, and now we want to check some number whether it's within this collection. So both lists and sets support the in statement to check whether some value is an element of those collections. But importantly, it works very differently, making it very, very slow for lists and very fast for sets. So when we do that in a list, what Python actually does, it just starts iterating through all the elements within the list, one after the other, checking whether the first number is that number, no, checking whether the second value, no, third value, fourth value, and so on and so forth. It goes as long as the list goes. Whereas with sets, we actually have a more efficient kind of lookup implemented under the hood. And again, this is something that we're going to dive more deeply into in an upcoming bonus question. But I will only say that Python actually has a more kind of efficient data structure behind the scenes. So you can think about it like checking within some ordered index. So if you have, for example, an alphabetical index, say in the end of some book, and you want to check whether something appears within this index, you don't actually have to iterate through every element within this index. You can use the fact that it's sorted and it's organized in some kind of organized data structure, and you can do the search much more efficiently. And actually sets work in a somewhat similar way, and that's, by the way, applies also to dictionaries. So when we try to do a lookup within a set or within a dictionary, when we try to get a value corresponding to a given key in a dictionary, we actually have an efficient kind of lookup going on. So whenever you need to do something like that, that could be a very good motivation to use a set instead of a list. Of course, in this example, it's not very important because, we just do it once. So even checking, 1 million elements, it's not something that terrible for a computer, which is sufficiently fast. But if it's something that we now wanted to do within, say, another loop, and it was part of a big program, and it happened quite frequently, this could be a very major difference, and it could make all the difference between something that is actually feasible to run on a computer and something which couldn't really finish in a reasonable time. Now, if we want to extend sets and to add new elements to them, we can use the add function. So you can see we can take the set and add 55 to it and add 1, which doesn't do anything because 1 was already within the set. Or we can add the string 1, and again, like all the other collections, Python doesn't care if you have a uniform data type or different data types. It doesn't care about the types. And we end up with a 5-element set like we see here. And finally, some useful operators that you can use for sets. So you can use this pipe vertical line character. This is actually, in order to produce this character, you go to the / key and hit the shift button. And then it will produce this kind of vertical line. And what it means in the context of sets, it means we want to get the union of two sets. So if we have one set on the left and one on the right, and we ask for their union, we get a new set, which contains all the elements that occur within either the first or the second set. So it's essentially merging them together. So you can see we get 1, 2, 3, 4, 5. So everything that is contained in either of those two sets. Likewise, we can use the ampersand operator to get the intersection of the two sets. So this will produce a set that contains only the elements that appear in both the first and the second set. So only the element 3 in this case, so we get a set with just one element. And we can use the minus operator to subtract one set from the other. So essentially, we take the second set and subtract it from the first one. So we end up getting only the values that appear within the first set, but do not appear within the second set. So only 1 and 2 in this case, because 3 appears in the second set. Okay, so that's pretty much all the Python syntax we wanted to cover today. And I think that's quite enough for the first lesson. Like I warned you, we go really fast, at least with covering the basic syntax of Python. It's something that we don't want to spend much time on. And like we saw, most of it is quite similar to different programming languages, which you know already. So we didn't really have to go much deeply into that. But I think this should give us a pretty good background of everything that you will need for the first exercises of this course. And now a final thing I wanted to say, and to conclude this lesson with, is the distinction between Python 2 and Python 3. Okay, so like I mentioned, for very long, people still used to work with Python 2. And even though Python 3 exists all the way back from 2008, until very recently, people still used it because Python 3 broke some important interfaces. And for many ongoing projects, it wasn't that smooth to do the transition to Python 3. So now, thankfully, the end of life of Python 2 has arrived. It was earlier this year. And I think now it's safe to say that most projects have done the transition and now use Python 3. But there are some lingering projects that still use Python 2, and it's still somewhat of an issue, even today. So, yeah, it's just something that I think is important to pay attention to. Of course, in this course, we work with Python 3. And I absolutely recommend that you also work with Python 3. I think there is no reason to work with Python 2 if you're just now starting to use the programming language. But it is something that I think is important to pay attention to, especially when you try to look online for answers to some questions or for some code examples. You might encounter people still using Python 2, and if you're not aware of this, this might confuse you. So there are some important distinctions between the versions. Things like printing, division, imports, and the way strings work. I won't get into it because, again, I think it's not that important right now. Something else that you might notice people do is use this kind of import syntax. So from future import, absolute import, division, print function. This is actually a way that people used to create some compatibility between Python 2 and Python 3. If you see this syntax, what it actually means that if you work with Python 2, with some respect, it will make it work more like Python 3. Whereas if you run it from within Python 3, it will actually do nothing. And this just helps people create code that works both in Python 2 and Python 3. So again, since you will be working with Python 3, I think there is no reason for you to use this kind of syntax, but be aware of that. And this is something that you might see people use. Okay, so with this small comment out of the way, I think we will really stop here. And like I said at the introductory of this course, I think it's absolutely crucial that before going on to the second lesson of the course, make sure that you do both the lab exercise and the homework exercise. They're very important, and like we said, the exercises are a crucial part of this course. I think the main part of this course. So make sure that you do the exercises and you try to solve them on your own. Okay, so take the time and open up the Jupyter Notebook and write some code and debug it. And only after you get it to work for you, to actually working, to running and producing the kind of results that you expect, only then do I recommend you to go to the solutions that we post on the website and see if your solution is similar to the kind of solution that we use and try to see what you can learn from it. Okay, so this applies both to the lab exercise and the homework exercise. Again, I think both are very important. And also, like I said, you have the bonus question. So in the homework exercise of this lesson, you will have the first bonus question. And this is actually a quite important bonus question. So this is something that will show up later in the course. So also make sure that you take the time to do some research, do some Google search, and try to come up with a satisfactory answer to this bonus question, because this is actually a topic that you will need later on. And like I said, this applies to many of the bonus questions that will appear throughout this course. Okay, so I think we'll conclude here, and I will be happy to see you in the second lesson of the course.